Today we're going to talk about fixtures and workflows in terms of the support and securing your parts. So we'll start by finding out what is fixturing. Fixturing is a process or means by which an object is supported and secured during a manufacturing process. So anything that you want to hold down before you do anything. You may be familiar with vices that you use to hold your stuff when you're trying to sew it down, or even when you use your knee to brace something when you're cutting it with a sword. That's a form of fixturing because you're trying to counter the forces that come with cutting something up, and that's why you have to hold it down. So in terms of fixturing, it may look like something simple, but mastery is achieved in fixturing when you are able to constrain all the motions and you anticipate all the motions that are going to come up. Like if you know you're going to use a drill, then you know it's going to be circular motion, and then you want to counter that force before you even apply yourself on that drill. It's something that you have innately with you if you've walked around tools for a while, but it's something that you need to develop, and with time you start to see what do you need to account for before you even try. And to get to that level, you have to the pride in the game is trying to use the least number of points, shortest setup, and the lowest cost, because you're trying to save yourself money. That's the bottom end, and also be safe at the same time. So physics comes important in fixturing because you need to see what happens before anything happens to your setup. So it's good to keep that in mind. Like if it's a lever, you know, if I push down on this side, the other side will go up. And I mentioned the drill before with circular motion. So imagine trying to walk on a ball. It's slippery and round, it moves around in all directions. So spherical objects are one of the trickiest things to fixture because especially if you're trying to drill through, like in this process, we're supposed to drill straight through the ball. And at the same time, you want to be able to set up your system quick and easy and put it down. There are lots of solutions out there that like using clamps or using wedges and stuff like that. But to me, I came up with this solution where it's already spherical at the bottom, particular radius close to its tolerance. You place the ball inside, and then you have the other end, which is concave, and you just put it inside because it has the two poles on it that fit directly to the already pre-drilled holes, and that way you can easily just put your sphere in, drill it, put it inside, cover it, and drill through, and the process is done. And you can do this over and over because right now the only motions we are trying to avoid is it spilling off to the sides. All right, in this scenario, it's grooved center drill on the flange. Most people will go directly to using uh, the lathe, and after you've done the lathe work to the material, the initial material we had to find a way to make it more secure with faster changeover times. So in this case, we decided to go with something that's already shaped like the flange itself, and you can see it has all those holes already pre-drilled where you can just use cheap wood dowels or something like that to put it in, hold it in position, do whatever you need to do, and then get rid of it as soon as it comes. So the main thing right now is another case of trying to avoid the circular motion that comes with it, and so you try to cover your ends that way. In this one, we do have a machine plate, and the initial material itself was a rectangle. So here we're also cutting and drilling using circular motion at the top. But we know that the weight of the material itself is going to hold it down, so we don't have to get concerned about that direction. The directions we need to do are the other four on the other side. So what we did is to already have a tray that's set up with four ends that's already in tolerance with the material we're going to work on, and we already have four holes drilled through, so we can place this on a desk or a workstation, and then just drill it through, secure it tightly, and then we can get in our pieces in and work on them and get them out as soon as we can. So we're saving a lot of time and costs with this particular design. The next one, we have the triangular stock. So here we have to drill through the middle of a triangular object, prism. So the trick was to just have something that's already cut that way in the middle of the base, and then you already cut through the holes on the side where you can drill through. So the thing is, you place your object in, it already gives you a guide to where the drill is going to go through, so you just drill a pilot hole on that point and get ready to set your drill at 90 degrees and drill right through the material, and then you can change the changeover time with this one will be particularly quick because you don't have any other things to account for when you're trying to do your setup. And then lastly, we have the thin stock groove. So we already have the block set up right there, and we need to simply add a simple extra groove on the top of it. So you can tell this was part of a larger material that we cut them down to size. So the simplest cost to me was you just come up with a wooden block and two sides that are already set up. You can nail it through, and then just place the other line on top of it, and then that way you can groove through without, it'll stop the lateral movements, and then the gravity will help hold the piece down. So we've accounted for whatever possible forces can show up in the middle of the process. Anyway, thank you for listening to my presentation about fixturing, and the trick is to anticipate what physics will do. Everything works on reality, and if you can anticipate it, then you're already your way to being a master at placing things safely. Thank you.